Okay, so I'm making my key for the Quiz 3 bonding practice test, and I just wanted to go ahead and make a video while I was doing that so that people who are having trouble with this or haven't been in class have a chance to go over it or learn about it for the first time. So we're going to be drawing structures for covalent molecules. Covalent molecules are created when two atoms get together and share electrons to form a bond. So it's different for ionic molecules or ionic compounds where they transfer an electron from one atom to another. Here they're going to be sharing electrons. But it starts out the same way because our first step is going to be to draw each of the atoms, the dots for each of the atoms that are in the structure. So in this case we have a bromine, and the formula tells us there's just one. Bromine is a halogen, so it is going to have 7 electrons. We know this from our tall group column number. I'm not going to be looking those up in this video, but I've gone over that in previous videos. Okay, so that's your tall group column number, 7 valence electrons, 1 single. That means bromine will make 1 bond. We also have fluorine, which is another halogen, and that has 1 single electron plus its 3 pairs for a total of 7 electrons. So I know each of these atoms now need to make 1 bond because they both have 1 single electron. Because I have 2 atoms and I'm going to have a covalent molecule, I must join them together. This is the only way that it can happen. And so I put this single electron over on this side. It doesn't really matter. When I draw the structure, I'm going to have to pretend that it was on the other side. We are just representing molecules here. So I'm going to draw bromine and I'm going to connect it to a fluorine because I know that's what has to happen. Both of these atoms are contributing an electron to this bond. That takes care of their single electrons, but we still need to draw in those lone pairs. That's going to be 3 lone pairs for each of these atoms, just like this. Okay, and I am going to talk about the shape of this molecule now. So anything that has just 2 atoms in it is going to be linear. That is going to be the shape for a 2-atom molecule. So I'm going to write linear. And I'm also going to talk about polarity here in this video. So polarity is depends on whether one atom in the structure is pulling electrons away from another. So basically, if the charge distribution is equal all over the entire atom, it will be nonpolar. But if there is more negative charge in one part of the atom than the other, and one part of the molecule than the other, then it will be polar. So the way we are going to figure this out is to look at whether the molecule is symmetrical or asymmetrical. So if the molecule is asymmetrical, that means the sides aren't the same, then we are going to say that it is polar. Okay, so asymmetrical means the sides aren't the same. I'll look at each molecule. Can I divide them in a way that makes the 2 sides different? The answer here is yes, because I have a bromine on one side and a fluorine on the other. So I am going to say that this is polar. All right, we'll move on to the next one. And I think for the rest of this video, I'm not going to talk about the polar, non-polar thing. I'll do that in a separate video. Let's just draw the structures in this one. Okay, so I'm moving on to difluoromethane. I'm going to draw that, the dots for that one. So I've got a carbon, 1 carbon. I've got 2 fluorines. That's going to be times 2, and 2 hydrogens for this one. With just 1 electron each because they're in the first column, and that is times 2. Okay, so important rule. You're always going to put the atom that makes the most bonds, or in other words, has the most single electrons in the center of a structure. You'll put that down first. That will always be carbon if you have carbon. So you're going to start out making the structure with carbon in the center. If you have a carbon plus 4 other atoms that make single bonds, your structure will always look like this, like a plus sign. Okay? That's going to happen a lot. Then we're going to put in our 2 fluorines and our 2 hydrogens. Okay, Now, do I need to add in any electrons? Not on hydrogen, never on carbon, but I do on fluorine. So I'm going to add those in, and I am done with that structure. I'll come back and talk about shape and polarity later. Okay, next thing, nitrogen trioxide, or trichloride, sorry, right here. Okay, how would I do that one? So start out drawing my dots, just like I did before. And so I'm going to draw nitrogen with 5 dots, 1 pair plus 3 singles, and my chlorines are going to have 7 dots each right here. And I'm going to put it times 3 since I have 3 of those chlorines. So that's what the number here tells me. Don't be confused. This chlorine, a C with an L after it, a straight line, is always chlorine, not a carbon and an iodine, okay? That is chlorine. Got to get that straight. So we put our atom that makes the most bonds in the center. That's going to be nitrogen because it has 3 single electrons. I'll draw that here. And then I'm going to draw my bonds coming out from the nitrogen, 1, 2, 3. And I have 3 chlorine atoms, so that works out perfectly. I'm just going to put them on like this, draw in my lone pair electrons on that atom. One more set. Okay, and I am done with that structure. Okay, next one, sulfur dihydride, right here. So we're going to draw both the atoms in that structure. And so, let's see, make sulfur, this teal color. Sulfur is in the 6th tall column. Haven't gone back to that in a while. That's right here, sulfur 6. It's going to have 6 electrons. And there's a lot of different ways I could do that. I go 1, 2, 3, and 4. And then I have to decide where I'm going to put my doubles. So for now, I'm just going to put my doubles at the top and the bottom, and we'll talk a little bit more about that. And I'm going to add in my hydrogens, which I think I was making those orange. So those are right here, and I'm going to have 2 of those. So because this is a lot like the structure of water, we know water is a bent molecule, and I kind of know that already. Anytime you have a central atom with 2 pairs, it's going to end up being bent. So I'm going to keep that in mind and draw this with that in mind, but you wouldn't necessarily know that unless you had some experience with this. So sulfur is going to be in the center, and I'm going to actually go ahead and draw my bonds sort of going down like this, and then I'm going to put my hydrogens on it. Now, if you were to draw this straight, I would not say that was wrong because we are still just learning about structures. Okay, and then I'm going to put my lone pairs on it like that. Okay, so that would be my sulfur, or my sulfur dihydride right there. Okay, next one, nitrogen gas. So we've got a nitrogen atom. Again, we know how to do that. We've done it more than once now. And so we have 2 of them though. And up here I said anytime you have 2 atoms, you are going to join them together. It is the only thing you can do to make a molecule. So I'm going to draw this with 1 bond. I'm going to put in my lone pairs, and I'm thinking, I have 2 more electrons to get rid of, right? Because I already made a bond here that used my 2 single electrons, 1 from each of these, but I still have 2 more single electrons on each of these atoms. What can I do? Anytime you have this situation, extra single electrons, and they're matched on both sides of a bond, you're just going to add in more bonds until you use those all up. So I'm going to add in 1 more, and then I'm even going to add in a 3rd. So when I have nitrogen gas, the atoms are actually triple bonded to each other, just like this. And it would be a linear molecule because it has no room to bend in that structure. Okay, hydrogen cyanide is a really interesting one that is again going to have triple bonds. So we have a hydrogen atom here, 1 single electron. We have a single carbon atom with 4 single electrons. And then we have good old nitrogen here with our lone pair and 3 singles. Okay, so always put carbon in the center, right? So I'm going to put that carbon down, and this time I'm just going to draw one line on either side of it for now because I'm not quite sure what's going to happen here. There aren't enough atoms to use all the bonds. I'm going to put a nitrogen here on one end because nitrogen has to make 3 bonds, so it's going to have to bond to carbon. And I'm going to put the hydrogen on the other end because carbon needs the most bonds, so I'm going to surround it. Okay, so now I've done that. That's my starting point. Hydrogen is good. It's got a duet. It can't make any more bonds, but I know the carbon is still going to need to use 2 more single electrons, right? And nitrogen also needs to use 2 more single electrons, so it has a total of 3. Since they both have more single electrons and it is matched on either side of this bond, I'm just going to add more bonds. So I'm going to add in one more and then another, and that is going to use up all those single electrons on either side of the bond. And I'm going to end up with happy atoms and a triple bonded linear molecule here because it's these triple bonds are really rigid and they don't allow the molecule to bend. And there are no lone pairs to shape this molecule differently. Okay, moving on to selenium chloride. Okay, so selenium is one that we don't do very often. We'll look that up. It is in the 6th column, just like sulfur and oxygen. So it is going to get 6 electrons. And we'll draw that here in purple, selenium. And I'm going to put that here. I think I know where we're headed with this. I think it's going to look a lot like the sulfur dihydride that we made. We're going to begin to see that certain atoms that are similar make similar structures. So selenium right here, I'm going to draw with, let's see, 2 more single electrons because I said we had 6. And then my chlorine, I'm going to draw here with 3 pairs, right? Plus 1 single, and I have 2 of those. Selenium makes the most bonds, so I will put that in the center. Se in the center. And, oops, you know what? I'm actually going to do that thing I did before. Let me scribble out that electron, and I'm going to make my 2 lone pairs here on selenium, both on one side, because I know that because it has 2 lone pairs, it's going to be a bent molecule, just like water and just like sulfur dihydride. So I'm going to draw my 2 bonds, put in my chlorines, add in the electrons on chlorine. Okay, and this is one of those things, anytime you have a central atom with 2 lone pairs, it's going to assume this bent structure, and if you build it with our molecular modeling kit, you will see why. But it's hard to explain when you don't have a 3-dimensional molecule. But basically, because the way that the bonding pairs are situated, or the single bonding electrons are situated, you're always going to end up with a bent molecule no matter which ones make the bonds or which positions make the bonds. Okay, so I think that we're done with that one. We're going to do one more on the sheet, and that will be the end of the video. That is methane. I made a mistake on methane, so this should be CH4 right here. So I'm going to have that central carbon with 4 atoms on it, or 4 electrons like that, and I'm going to have 4 hydrogens. Okay, just like that, and that's going to be times 4. Okay, so whenever I have a structure with a carbon, it's going to go in the center, but especially when I have a single carbon with 4 other single bonding atoms, I make the plus sign, right? Just like this. I put the atoms on the ends of the plus, like this, and I end up with a beautiful molecule, and we'll be learning about shape, but that will be a tetrahedron and also nonpolar. Okay, thanks for tuning in, and I look forward to seeing you in class. I hope this helped.